Hello guys, I'm Apurva Khernar and I'm here to talk about my third technical task as a data science and business analytics intern at the Sparks Foundation. In this task, I had to develop and visualize a decision tree for the iris dataset. So similar to my previous two tasks, I imported the libraries and modules first, and this time too I have used pandas, numpy, matplotlib, seaborn and sklearn. In the next step, I loaded the iris dataset into a data frame, and here the species or the dependent value that is defined in the target column. And in this one, 0 stands for setosa, 1 stands for versicolor, and 2 stands for virginica. Then I visualize the available data using dist plot and swarm plot as well. So in the swarm plot, you can see how the features vary from species to species, and how they are different for each one. Then for developing the decision tree, I first defined the features and labels, initialize them in two variables, and then I split the data into training and testing sets. I did this using the train test split function from sklearn, and I used 75% of the data for training and 25 for testing. I have defined the test size as 0.25 over here. Then in the next step, I use the decision tree classifier function from tree module and fit it over the x and y from the training set. Then I visualized it using tree.plot tree, and here you can see. So as you can see here, the petal width is the most useful feature to separate the setosa species from the other two, because after this first box, the setosa species does not occur anywhere in this tree. All the samples are classified here itself. The petal width feature is used later as well, but it is very much useful in classifying setosa. Then I tried to predict, and I tried to implement two approaches in the predictions. So first I predicted over the testing set, and here you can see that out of 38 samples, 37 were classified correctly, only one was misclassified. Then the second approach that I followed was I used cross validation, tenfold cross validation. So many of you might be familiar with it. And this was done over the entire set. And here, out of I guess 150, 6 were misclassified. You can see these 6 were misclassified, but still that's a good score. Then I, just to check, I evaluated these models using the R2 score, the tree dot score, and also visualize the confusion matrix in the two approaches. So you can see the confusion matrices over here, this and this one. So this was the procedure that I followed in developing this decision tree, and I think that I have got satisfactory results, in fact more than satisfactory. And I would like to get more suggestions from you and corrections if there are any in the comment section. And thank you very much, and I hope you liked the video.